Hi everybody, I'm Christian, I'm from Group Papa, and I want to tell you a little bit about what we've built. And that starts with a universal truth. And that truth is that DJing is cool. You know it's true. Think about it. In that moment, you have an entire audience at your fingertips. The slightest movement will change how people are feeling, what they're moving, everything that they're doing. And it's a lot of fun as well. But there's a big problem with it, and that's that getting into DJing is hard. There's all sorts of complicated software that is really hard to understand, requires all this extensive knowledge and all this practice. And it's really expensive to get into. There's just so many barriers for getting into DJing. And that's what we, Group Papa, want to do. We want to break barriers for getting into DJing and for doing DJing. And we believe we've achieved that with our product, V-Rave. And essentially, V-Rave is intuitively DJing in virtual reality. And I want to pass it over to Smriti, and she's going to tell us a little bit more about the tech that it's built with.
Thank you, Christian. Sonic Pi is a platform for algorithmically describing music, and we saw this used by Sam Aaron, and he also developed it. He used it earlier in his set before these presentations. One of the basic building blocks with Sonic Pi is the live loop, which represents a piece of music continuously playing, and we use this as a building block for V-Rave. One of the technical challenges with using Sonic Pi was that you communicate with it via code and shared memory, and this was hard to expose to our VR platform. The Oculus Rift is one of the most popular VR platforms today. VR offers a really new and immersive experience for DJing. DJs can literally feel the music and focus on music creation. One of the technical challenges and difficulties with working with the Oculus Rift is that I've been watching too many Transformers movies. One of the difficulties is that you need a Windows platform to develop. Not all of our members had this platform, so we got around this using WebVR. Finally, we allowed for interesting input into our virtual reality space using the Mayo gesture control armband, which allowed us to interpret motion digitally and allow for different interesting controls. One of the difficulties with this is that the data was not always accurate, and it was also different for different people. I'm going to pass it off to Chris now, who's going to talk a little bit more about how to use it.
So on the interaction side of things, we've got this cutting-edge hardware that we've got to play with, and on that note, we want to talk about the interaction principles that we came up with when we began the product. And that's basically that it's easy to use. Anyone can put on a headset, put on an armband, and make some really great sounding music with it. And to sort of step away from the illusions between professional DJ software, we've come up with this visual style wherein these different shapes we have here, the platonic solids, correspond to different categories of music that you can drop in the world. And we're using the head tracker on the Oculus Rift to select objects in the world. And then 4 gestures we have with this Mayo control armband. So you can use a fist to select objects, a wave gesture to go through effects like reverb and whammy, and a rotate for volume control. And as you can see on there, this is one we made earlier. And I'm going to pass over to Rowan now, who's going to talk about what's next.
Okay, yeah, so when we were doing this project, we quickly realized we were limited by the 6-week development period. And there's a lot of potential as to where we can go from here. One thing that was key to us was maintaining both usability and functionality. So making a product that you can pick up and play with, but also something that you can use as a serious DJ tool. These areas are not mutually exclusive, and we think we can make both better. So on the side of usability, one thing we're very keen to implement is Fourier transforms to make our visualization data more specific. So currently you can see how each loop is changing size based solely on amplitude, but that could be made more specific. We also want to look at other inputs, because the Mayo is kind of a limitation. Another thing we want to look at in usability is cheaper hardware, so like porting it to Google Cardboard. On the side of functionality, this is about power users. So we want to make it so Sonic Pi basically has a lot of untapped potential, and we think we could make use of that. You could make it so you can edit loops on the fly or import your own samples. That about wraps things up. Thanks to Matt and Ed from Frontier Games, and thank you all for listening.